Today, we're going to tackle the biggest story there is, the entire 13.8 billion year history of our universe. We're going to trace the journey from an unbelievably hot, dense beginning all the way to the vast, star-filled cosmos we see today. So let's dive in right at the start of everything. I mean, it's the ultimate question, isn't it? You look up at the night sky, you see all those stars and galaxies, and you just have to wonder, where did all of this come from? How did a universe that seemingly came from nothing become, well, everything?
So our story kicks off at a moment before time as we know it even existed. And this wasn't some explosion happening in space. It was the creation of space itself, a single sudden event that brought all the time, space, and energy the universe would ever have into being.
To really get how we got here, we have to start at the very, very beginning. I'm talking about the first impossibly small fraction of a second. This is the moment when the fundamental rules of our entire reality were written. The speed of what happens next it's mind-boggling. Before you could even think about blinking, the universe goes from this point of unified physics, what we call the Planck era, to this insane period of growth called cosmic inflation. In way, way less than a trillionth of a second, it just ballooned in size, setting the stage for literally everything that came after. And get this, just 1 second after the Big Bang, the universe was this scorching 18 billion degree soup of particles and energy. To give you some perspective, the core of our sun is about 27 million degrees Fahrenheit. This was over 600 times hotter, just an environment of pure chaotic energy. So why does the universe seem so flat and uniform when we look at it on the biggest scales? Well, cosmic inflation has this really elegant answer. Imagine you have a crumpled piece of paper, right? If you stretch it out until it's gigantic and you're standing on it, it's going to look perfectly flat from your point of view. Inflation basically did that to the fabric of space-time itself, solving what cosmologists call the flatness problem. Okay, let's jump to the next huge phase. For hundreds of thousands of years, the universe was basically a blinding, opaque fog. But then, something pivotal happened that allowed light to travel freely for the very first time. For the first 380,000 years, the cosmos was like being inside a super dense fog. Photons of light just couldn't get very far before smacking into a free-roaming electron. But as the universe kept expanding and cooling down, atomic nuclei were finally able to grab onto those electrons, forming the first stable atoms. And just like that, the universe became transparent. The fog cleared. And that light, the light that was released at that exact moment the fog cleared, it's still traveling across the cosmos today. We can actually see it. We call it the cosmic microwave background, or the CMB. It's, for all intents and purposes, a baby picture of the universe. It's the afterglow of creation. So what was the universe even made of at this point? Well, compared to today, it was incredibly simple. In the first few minutes, a process called Big Bang nucleosynthesis cooked up the very first elements. You had about 75% hydrogen, 25% helium, and just the tiniest traces of anything else. These were the basic building blocks for everything to come. After that initial flash of light faded, the universe entered this long, quiet period. There were no stars, no galaxies, just darkness. But under the surface, an invisible force was starting to assemble the grand structures of the cosmos. They call this period the Cosmic Dark Ages, and for good reason. For about 200 million years, the universe was just filled with this neutral gas, hydrogen and helium, but with absolutely no sources of light. It was a time of quiet, slow, and patient gravitational construction happening completely in the dark. And this brings up a really fascinating puzzle. Right? If all that matter was spread out so evenly, how did it start to clump together and form the first stars and galaxies? Normal gravity working on normal matter just isn't powerful enough to explain it. Something else had to be going on. And the answer, scientists are pretty sure, is dark matter. We can't see it, we can't touch it, but we could definitely see its gravitational effects. Think of it like invisible cosmic scaffolding. Its immense gravity created these deep pockets that pulled in all that ordinary gas, creating the seeds that the first galaxies would eventually grow from. Now, what's truly wild is just how much of this invisible stuff there is. All the stars, all the planets, all the gas we can see, everything we think of as the universe, that makes up only about 5% of its total mass. Dark matter, that invisible scaffolding, outweighs us more than 5 to 1. It's kind of humbling. So, Thanks to that dark matter scaffolding, these huge clouds of gas started to collapse under their own weight. The centers of these clumps got denser and hotter until, boom, nuclear fusion ignited. The first stars roared to life, ending the cosmic dark ages and lighting up the universe once again.
For billions of years, the story of the universe was basically this tug of war between the outward push of expansion and the inward pull of gravity. But then, about 25 years ago, scientists made a shocking discovery that completely turned our understanding of the universe's fate on its head.
I mean, it makes sense, right? With all the matter and dark matter in the universe pulling everything together, you totally expect that the expansion from the Big Bang would be slowing down. For decades, the big debate was if it would slow down enough to eventually collapse back in on itself. Well, the answer, incredibly, is no. In the late 1990s, astronomers looking at distant supernova found the exact opposite was happening. Not only is the expansion of the universe not slowing down, it's actually speeding up. The reason for this acceleration is maybe the single biggest mystery in all of physics today. Scientists gave it a name: dark energy. They think it might be a property of space itself, an energy built into the vacuum that acts like a kind of anti-gravity, pushing everything apart. So here it is, the complete and frankly mind-bending picture of our reality. Everything we know, everything we see, everything we're made of is just 5% of the universe. The rest is made up of 27% invisible dark matter holding things together and a whopping 68% mysterious dark energy pushing everything apart. We live in a cosmos that is almost entirely unknown to us. And this leaves us with one final profound question. Our 13.8 billion year story has taken us from a single point of energy to a vast accelerating cosmos. If this mysterious dark energy keeps doing its thing, pushing galaxies away from each other faster and faster, what does the future hold? Will the universe just expand forever until it's cold, dark, and empty? That's the question that drives cosmology today.